Hello, welcome to your second video of this chapter. This is the scientific method, and so you've probably heard about the scientific method since the very beginning of your science experience. And so this is going to be relatively quick. If you go on to anatomy next year, I do not plan on talking about the scientific method. But we're just going to talk about some basic things. This is the section 2 of chapter 1. Remember, don't focus too solely on the chapter numbers and the section numbers. All right, so here are our objectives. For this particular section, you should be able to describe how the approach to science was changed in history, identify the steps of the scientific method, distinguish the difference between the independent and dependent variable, and describe the various methods of communication in science. The biggest point here is the third bullet. I want you to make sure that you are able to identify or distinguish the difference between an independent and dependent variable. That's pretty much the key to this. When we do labs, being able to identify those variables is super important in being able to have having good results. And you'll see that as we progress through the year. All right, so before I begin reading off the slides, I do want to talk about a little bit of the history of the scientific method and talk about a little bit of history when it comes to science. I didn't type it out, so usually when I don't type it out, I don't really see it as like the most important portion, but it's good to know our background. So basically, science is pretty young, and it was pretty well established within the Renaissance era. It was basically when Europe was in a really like a time of growth. And so the Renaissance is the time where you see people like Nicholas Copernicus and Leonardo da Vinci and these types of people that are really well established in their areas and their fields of study. Leonardo da Vinci, like the all-around man who's really great in science and inventions and different things like that. And so that's really when science began to progress forward, and there were observations that were made. There was more of a systematic approach to these things, so it wasn't like somebody was just asking a question and then figured out the answer. It was a time where people were really, really focused on knowing why things were the way they were. So, for example, questioning if the sun is in the center of the universe or if the earth is in the center of the universe. That was a huge debate within that time frame. Leonardo da Vinci wanted to make people fly, and he wanted to understand the human body. Leonardo da Vinci pretty much wanted to do everything. But this is really a time where it led to the advancements in like astronomy, physics, anatomy, biology, chemistry, all sciences. This is really where things really progressed. Now, the scientific method is really how science is worked around. It's really that systematic approach, that organizational piece, because if you're not organized and you find that your thoughts are scattered, you can find that you're going to either lose data, you'll forget something. And so this is a way that scientists use to make sure that their experiments are running in a nice direction, in a direction that they're hoping will achieve the results that they are hoping for. So, like I said, the scientific method is a systematic and logical approach to the acquisition of knowledge, and that's really nice long words there, but basically it's systematic and logical. It's just a series of steps that you get when you ask yourself a question and how you can answer that question. I did not list the steps here in class. When we take our notes or when we're talking about this, I will give you a picture of a nice scientific method, and I'll explain different areas of stuff. Now, like I said, series of steps are necessary to avoid assumptions and bias. So a lot of times scientists will assume they know an answer to something just because it appears so. The scientific method takes away those assumptions, it takes away those biases, and it allows the scientist to view in the eyes of just a scientist, not view in the eyes of a mom or a dad or a boy or a girl or anything like that. I shouldn't have said I didn't list the steps. I did list the steps, but I guess I didn't list like the chart. All right, so step 1, you're always going to have a question. That is how the scientific method starts. It's by formulating a question. So for example, Jace wakes up and he is screaming. Okay, so the first thing I'm going to think is, why is Jace screaming? If you know my kid, you know that he generally he's a little bit of a drama queen, and once you get to know me, you'll learn that I am a little bit of a drama queen. So really, the apple doesn't fall too far. Anyway, Jace is screaming. Why is Jace screaming? And then you go into forming a hypothesis. So a hypothesis, the book definition is a testable conjecture that proposes an answer to the question. So remember, my question was, why is Jace screaming? And I'm proposing an answer to this question. And so I'm saying Jace is screaming because he wants cereal. So that is my hypothesis on why Jace is screaming. It doesn't mean it's correct. It doesn't mean anything. It just means that I am coming up with some sort of answer. And that's exactly what you would do in science. Obviously, you would make it more advanced than why is Jace screaming. But literally, this is probably my morning about 3 of the 5 days of the school week. So hopefully this year goes a little bit better. The next thing you're going to do is you're going to test that hypothesis in the form of an experiment. So here we go. Jace is screaming because he wants cereal. I pour him cereal, I give him the bowl, and what does Jace do? He still screams. Okay, so I ran an experiment. What happens? Oh, it doesn't work, so I revised my hypothesis. Okay, so what I found was Jace was still screaming. He didn't really care for the cereal. I experiment again. I then go on to analyze my results, and I find out Jace doesn't like the cereal. So like I said, I revise that. I experiment until I find the answer. And then I develop and revise my hypothesis. So now Jace is screaming because he wants cartoons. All right, so I go and I do another experiment. I put on some cartoon, I don't know, like Paw Patrol. And oh, look at that. Jace is sitting down all happy. There we go. And there is my morning scientific method steps every day. So lucky me. Like I said, I will give you a chart in class of the scientific method. So don't freak out if you really like not following along with my steps and not following along with my examples. We'll talk about this more in detail, and we'll talk about it with a much better example. What I did not put in a slide, and I cannot believe I forgot this, and I'm just noticing it now, so great for editing, right? I forgot to talk about theories and scientific laws, so please don't let me forget that in class. Go ahead and probably put a space or something, or leave like 5 or 6 lines before you talk or write scientific communication, and put developing theories and scientific laws. If you are following along with the readings that I have attached, you'll see that. And I've completely skipped over that chunk of information. So I will talk about that in class. So you will want to open some notes or leave some notes so that we can put those definitions in. All right, so scientific communication. The main things I want you to know about is that communication is done in so many ways in science. So I know you guys are probably thinking, well, this is science class. I don't even need to write anything. Well, you're wrong, because you are going to be communicating your results to me. And so I'm not expecting, because I'm obviously like the worst speller, and I don't have the greatest grammar skills all the time, but I do expect you to at least be able to write a sentence and to have like semi-good grammar skills. Because you will be writing lab reports, and these lab reports will show me what you have done in an experiment and what your results were. And so you can get results and you can communicate those results in a number of ways. A lot of times you'll see them in science with graphs and tables. We will be practicing how to write graphs and tables a lot in this class. Pretty much exclusively for every single lab, you are expected to know how to write a graph and to know how to come up with a table. Scientific journals are great ways to communicate, and so a lot of times these journals, they're really like just a huge booklet of different articles, and those articles contain different information and different experiments, and so that's a lot of times how people get their results out to the scientific community, because there are thousands of people in thousands of different labs doing so many different experiments. And so how people communicate those results is through scientific journals, and there are a lot more famous journals than others. And then finally, social media. Oh my gosh, I meant media. Social media. That is a huge way, and that's a huge advancement in our technological time. So you guys are living in a time that is incredible, because you guys can see science happen in the real world at any second. So there are like live streams of people doing science experiments all the time. So you're really living in a time where you have such an advantage as to the information around you, discoveries that are happening right now. Somebody could discover a new species within the ocean, And then boom, you would know about it the next day instead of waiting months for a new book to publish. So really, we are at a great time in science. Now, if you are following along with the reading, which I hope most of you are, because it really does give you a lot of information, more than I give in these videos, but it also gives you a lesson summary at the end, and then there are questions at the end of each section. I do not make these an assignment. These are for you, but what I can tell you about these questions is that I can guarantee that at least one or two of these questions will be seen on your test. So if you do the questions at the end of each section, you're pretty much doing parts of the test. So it's quite an advantage if you're taking that and using that as a resource. All right, if you have any questions, ask me at the end of this video.